right, well, as we get back into our study of geometry, we've been looking at proportions, a lot about proportions. This proportion, that proportion, this may be based on proportions, even like the Pythagorean theorem was based on proportional quantities. Everything had to do with proportions. And today we're going to begin looking at how we can construct proportions. Construction 17 in your notebooks. So construction section of your notebooks, construction number 17. I'm going to teach you how to construct the fourth proportional. Construct the fourth proportional to three given segments. Construct the fourth proportional to three given segments. Once you have that down, right below it, if you would, go ahead and draw three lines of varying lengths. I'm going to go ahead and start with a medium-sized line, then a longer line, and then finally a shorter line. I'm going to label them A, B, and C. So three lines, which I'll call A, B, and C, of varying lengths. We want to construct the fourth proportional to these segments. Now, in theory, we could measure these segments. In fact, go ahead and do that. Go ahead and measure, and I'm going to recommend using centimeters. I think that's going to be easier for you if you use the centimeter side of your ruler to measure here, so that's what I'm going to do. We're going to kind of use this as a check to see how accurate we can be. Now, of course, this immediately presents the possibility of error, right? You could measure incorrectly. You could read the instrument wrong. The markings on the instrument could be wrong. So this is why we're not going to call this a construction, but theoretically, we could make a proportion. 28 in my case is to 45.5 in my case, as 22 is to x. And I could cross multiply. In fact, I'll do that yourself as well. A is to B as C is to x. And let's see how big your fourth proportional line, if you measured correctly, should come out to be. Theoretically, I should get 35 3/4 centimeters. Yours, of course, will be much smaller, given that you're drawing on a piece of paper, not a chalkboard. But go ahead and figure A is to B as C is to x, based on the measurements you got, and see what your fourth proportional should come out to. Now again, to just draw a line of 35 3/4 centimeters is not a construction. That's a measurement that assumes I measured correctly, which I probably did. I should be able to measure correctly. But we're going to construct it in such a way that presumably, if we did the steps of the construction perfectly, it should come out to exactly that if my measurement is correct. Now, for every construction that we do, we base it off of something that's previously proven. Some previous time in the year, we've proven something about a fourth proportional. So I want to take you back to one of your pictures in proportions. You may recall this picture. A triangle with a line drawn parallel through two sides of the triangle. We said that if you draw a line parallel to one side of a triangle, it'll divide the other two sides proportionally. So that bottom is to top as bottom is to top, or holes to top as holes to top, or holes to bottom as holes to bottom, right? Or we could say top is to bottom as top is to bottom, right? That would simply be the inversion transformation, right? Of bottom is to top as bottom is to top. We're going to construct that. You realize if I can make a triangle that has two sides with segments of A, B, C, and something, and then these two lines were to run parallel, this something would have to be the perfect fourth proportional, correct? That's what we're going to do. Go down to the bottom third of the page. Step number one is to draw two long lines for the sides of the triangle. Draw two long lines for the sides of the triangle. So these two lines here will represent the sides of the triangle in my sketch. From here, frankly, you could probably deduce the steps to follow, but since it's a memorized construction, I'll give you the steps that follow. Step number 2 is to mark off the first 2 segments in succession on one side. Mark off the first 2 segments in succession on one side. So I'll measure off, mark off the first 2 segments in succession on one side. So I'm going to measure my first segment. I'm going to come up here to the vertex of the triangle. I'm going to make an arc. I've marked off my first segment, segment A. But I said to mark off the first 2 segments in succession. So now I'll measure segment B. And in succession, meaning where A leaves off, B begins. And there's segment B. So mark off the first 2 segments in succession on one side. Anyone want to hazard a guess for what comes next? As we look at the sketch, notice we've marked off A, we've marked off B.
Mark off C.
Yeah.
Mark off C.
Mark off the 3rd segment on the other side. Mark off the 3rd segment on the other side. So back to the vertex, just like the sketch would show, and mark off your 3rd segment, C. So far, everything's been incredibly intuitive, right? In fact, if we were plotting main points, I know this point, I know this point, I know this point, I know this point. You realize, though, I cannot mark off x because I don't know x. Now you say, well, we calculated x. Right, that's fraught with error. We're going to use that kind of as a check to make sure we were pretty close. What do you suppose, looking at the sketch, we could draw next?
Parallel.
The parallel. Now again, the idea is normally that you start with a triangle and then you would make the parallel. But I can't make the triangle because I don't know where the bottom of the side is, right? So I'm actually going to start by drawing what we normally call the parallel. Step number 4 is to draw a line between the ends of the 1st and 3rd segments. Draw a line between the ends of the 1st and 3rd segments. Or draw the line, I should say. Draw the line between the ends of the 1st and 3rd segments. Essentially, we are drawing the parallel. So again, normally, we would picture the triangle and then maybe constructing the parallel. But you realize if I know the parallel, I could actually construct this line so that it is parallel. Does that make sense? That's going to be my next step. Construct a parallel to this line, meaning the line we just drew. Construct a parallel to this line at the end of the 2nd segment. Construct the parallel to this line, meaning the line we just drew, at the end of the 2nd segment. And in parentheses, put construction 9. Construct the parallel to this line at the end of the 2nd segment. And this is construction 9, C-9. So remember for construction 9, we were supposed to have a transversal, which we have already. We were supposed to make an arc between the parallel, between one line and the transversal, and then come to this point down here and make the same size arc. So make an arc, make an arc. Then, of course, measure across the arc that we know. Really, more than anything, we're copying an angle, right? Because that's what making a parallel involves, is copying an angle. Measure across. Measure across, and as you connect the dots, you will be making a parallel because corresponding angles will be equal. And so now do you see we have formed a triangle in which there is a parallel. So we know that top is to bottom is top is to bottom. And that means that this segment right here must be our fourth proportional. Yes, sir?
I don't know what I did wrong on mine.
You didn't mark off your segments in succession from the top.
Oh, from the top down.
Okay, looking at the sketch, do you see how A comes down from the top?
Yeah.
And then B would be next. So erase it and start over when we do the next one. Okay, we're going to do another one of these in just a moment. We're going to do it on the back of the paper, you do it on the front of the paper. So go ahead and take your eraser of that and we'll restart. For those of you who are finished, measure your fourth proportional and see. I'm going to see, is it 35 3/4 centimeters? Did I do everything perfectly? Now the chalkboard is kind of hard to do, but it's worth checking. I'm at 36.3, so I was very close. I was less than a centimeter off. So for me, that's really good at the chalkboard. You should be within about a half a centimeter for yours, since you're able to use pencil and paper. How'd you do?
Very close.
Very close, good. Pretty close? Pretty close. Anyone right on, like you nailed it? Your construction was perfect, or perhaps your math and measurement was perfect. Because again, we don't know that your construction was off. It could have been your measurement or your calculation that could have been a little bit off. All right, any questions at all on this construction? Turn to the back side of the same paper and let's do it again. On the back side of the paper, let's do it again. This time, let's make the lines progressively shorter. Let's make the lines progressively shorter. So let's start with a long segment, then a medium segment, then a short segment. Let's go long, medium, short. And again, let's just call them A, B, and C, because we're boring like that. What should we do first if we want to construct the fourth proportional to these three segments? Jamie?
We should draw two long lines for the sides of the triangle.
Good, we're going to draw two long lines that are going to be the sides of the triangle. Again, this is based on the Theorem 53 picture. Two long lines, these are the sides of the triangle. What next, Chris?
Mark off first and second segments in succession on one side.
Okay, so kind of walk me through step by step what we're doing here. We
place your point of the compass on the end of one end of line A, and extend it to the other end of line A.
Good, so measure line A, or segment A, okay.
And then go to the vertex angle of the triangle.
Good, come up here to the top.
And then mark off. And then go back over.
I'm going to go ahead and label this real quick. All right.
And go over to B. And do the same exact thing.
Right, measure B.
Yeah, and then take your point of the compass and put it on the line you just made.
Good, the arc I just made, rather. Good, not all the way back to the vertex, but in succession as to where we left off with A.
And we'll create a mark.
And we'll mark off B. All right, then what? Genesis. Measure C. Do we mark that off in succession as well, Genesis? No. What do we do with C? Back to the top, but on the other side. And mark off C. All right, then what, Ethan?
Commit dots, the first one on the line on the left,
Good. Join the first and third segments, or the ends of the first and third segments. Now, again, you can tell that our triangle's a little bit slanty here. Okay, we're going to be kind of looking at it crooked like this, but that's okay. All right, then what? Quentin? Good. This is technically the parallel, so we need to have another line parallel starting here at the bottom of B that runs through here. And to make lines parallel, we need construction 9, which uses equal angles, corresponding angles, right? So we're going to copy this angle right right there. And that'll get me my parallel line coming across. So remember, I'm going to extend my compass just a little bit since it's kind of a small angle. Bigger compass makes up for that. That way I don't have a teeny tiny arc to measure. I don't like teeny tiny arc, but we want to make sure it still stays within the confines of B, the segment. All right. All right, so make that arc, measure it, make another arc, measure that. Well, make an arc, measure, measure. And then, when we connect the dots, we should have our triangle. Top is to bottom, as top is to bottom, there's our fourth proportional. If we cared, we would take time to measure the segments, but for sake of time, we won't. How many feel like I think I've got this now? Seems pretty intuitive, especially based off the Theorem 53 picture. Are any questions on this? Now, the nice thing about this is a very flexible construction. You can use this for several things. For instance, on another sheet of paper. Now I'm going to get out another sheet of paper. This won't necessarily go in the notebook.
Can I choose the back of this paper?
Let's not for sake of the notebook. And if you would, go ahead and draw 3 lines again. And this is how you pick how long you want them to be, whatever they want to be. Just don't make them equal to each other. So I'm going to go, I think I did progressively shorter last time. I think I'll go progressively longer this time. And again, we'll call them A, B, and C. Suppose I told you to construct X equal to AC divided by B, meaning the length of A times the length of C, all divided by the length of B. Now, one way you could do that, not in construction fashion, would be to measure A, measure C, multiply those together, then divide out whatever B is, all on the calculator. That assumes you measured correctly and all that. Or we could find a way to turn this into a proportion. Now, 11th graders, you took the last construction, so now we go to our 10th graders. How could I turn that statement, that equation, X is going to equal AC over B, how could I turn that into a proportion, either of you?
Is this going in the book?
No, this is not in the notebook. I already specified that. This is just on extra paper. Okay, to get what? Okay, so if you multiply both sides by the LCD, it gives you this statement. All right, then from there, you say we can turn that into a proportion? Kendall, help for your friend. Yeah, absolutely, because if you can turn this into a product of 2 quantities equal to a product of 2 other quantities, then you can make a proportion, Kendall.
A is to B as X is to C.
Good, as long as the A and C stay together, as long as the B and X stay together. Now, here's the problem. My construction that I just did a moment ago used X class as the 4th proportional. You can't do the construction without X being that 4th spot, right? It's got to be the 4th spot. Or perhaps, I guess one can argue maybe the 2nd spot. Instead of marking off segment, segment, get the parallel, you could go segment, segment, but it's got to be in either the 2nd or 4th spots, right? And right now, that X is in my 3rd spot. Audrey, I really want the X to be the 4th proportional. Thoughts? Flip, just flip right here and say A is to B as C is to X? Flip both. What do we call this, Audrey? Not alternation, the other one. Class? Inversion. The inversion transformation where you flip both ratios. There's the proportion. Do we see if we can construct B is to A as C is to X, then X will have to equal AC divided by B. So let's go ahead and do that at your seats. Go ahead and construct that proportion using those 3 given segments. Start, of course, with the 2 long lines, the 2 sides of the triangle. But we're not going to start with A, class. What do we start with?
B.
B. Must start with B. We're following what the proportion tells us to do here. So measure your B. Mark it off. Then what, Audrey? Measure A, because that's what the proportion says to do next. Then what, Kendall?
Mark off C on the other side.
Good, the proportion right here says to mark C next. So measure C. There we go. Mark it off on the other side from the vertex still. Audrey, then what? Say that again. B and C, the ends of B and C. All right, Kendall.
Construct parallel to that line.
By copying the
Angle.
angle here. Arc. Arc. Measure. Measure. Ooh, this is going to be tight. It might fit, or I may have to extend a line. Oh, looks like it's going to fit. Barely. Just. Barely. Ooh, cut that close. And there we go. And again, if we wanted to, we could go ahead and measure A and C, multiply their lengths, find the measure of B, divide that away, and see if our X really does equal that. But for sake of time, we won't. Certainly something you could do. Questions on this? How about this? Let's go ahead and maybe on the other side of the paper, or maybe if you still have some room on that front side, I just want you to draw 2 lines this time. And make a small line. Well, not small, smaller and larger. Let's make the smaller line, we'll call it K. And the longer line we will call E. Shorter line we'll call K, and the longer line we will call E. Just because it makes Kendall smile when I use the first 2 letters of her name.
Is it really because E is bigger than K?
Ethan speculates maybe because E is bigger than K. I don't know. Anyway, I want to construct a third line, which we will call X. And I want to construct X so that it's equal to the square of K divided by the length of E. The square of K divided by the length of E. Okay, Ethan, thoughts?
Well,
Squaring a line, that's just kind of interesting, right?
I'll do it.
What?
2Ks.
Okay, so there's a thought. So really what we're saying is that X is equal to KK over E.
Whoa.
It's okay, there's only 2 of them, right? We didn't cube it or anything, calm down. All right, so it's equal to KK over E. Okay, so continue the thought. Quentin, help him. Okay, so if we multiply by E, that would give us EX equals KK. Okay. Ethan, does that help trigger a thought?
Make a proportion.
Okay, let's make a proportion. What proportion are you thinking?
E is to K as K is to X.
E is to K is to X. And I like that when Ethan set it up, he made it so that X would fall in that fourth spot, though X isn't the fourth proportional.
It's the second.
Third. It's the third proportional. Notice this time we have a mean proportional, don't we? I don't know what that says about K, that it's mean, but anyway, it's the mean proportional. Just kidding, Kendall's a very sweet girl. But anyway, E is to K is to X. At your seats, construct X so that it's the third proportional to E and K, or in other words, so that X is equal to K squared divided by E. Doing it at your seats. Positive. Nice thing about a third proportional is you have less to measure. Once you mark off the K off at the bottom of E, you go back to the top and keep that same measure. Mark it off, that helps things to move along quickly. Wow, this is going to be a very small segment. Even smaller than K. There it is. Questions? How many had this same construction looking very similar? Excellent. Any questions at all on construction 17? All right, next sheet of paper in your notebooks. Next sheet of paper for your notebooks, construction 18. Construction 18. And this is going to seem very familiar to you. Construction 18 is to divide a line proportionally. Divide a line proportionally. I can't spell. Proportionally. Divide a line proportionally to any number of given segments. Divide a line proportionally to any number of given segments. If you would, go ahead and draw 3 lines. We could do 4, 5, 6, 7. It doesn't really matter, but let's just do 3 for sake of ease. Draw a short line, a long line, and a medium-sized line. Let's call them A, B, and C. You notice A is not offended by being the short line.
But why is C medium? Why can't C be the tall one?
It's just not. All right. C is offended by not being the tall line. All right, anyway, the long line, I should say. All right, now, if you would, kind of next to these lines that you drew, draw another line that's a little bit bigger than B. Draw another line that's a little bit bigger than B. You understand it is highly unlikely that this line that I drew at random would be exactly the same length as A, B, and C added together, correct? Therefore, if it is not exactly equal to A, B, and C, I cannot divide it up into A, B, and C, correct? But I can divide it proportionally into segments that have the exact same ratio as A to B to C. I'm going to call the segments A prime, B prime, C prime. Are we going to see a small segment, a longer segment, and a medium-sized segment that are exactly proportional to these? How might we do that? Well, think back a moment to, remember the picture where we had multiple parallels and a couple of transversals. Now, the transversals there didn't connect, but imagine for a moment if they did. And imagine that this segment was A, this segment was B, and this segment was C. These three segments have to be exactly proportional to these. They're not equal to A, B, and C, but I could call them A prime, B prime, and C prime, couldn't I? And if I had more segments, I'd maybe have a really tiny segment D, while I have a really tiny D prime. They wouldn't be equal to A, B, and C, but they'd be proportional, remember? Well, now imagine turning this sideways. And now here are your parallels. And here's A, here's B, here's C. Then there'd be A prime, B prime, C prime. Does this look like a construction we've done before? This is where we divided a line into equal numbers, into segments that were equal. Here we're going to divide into segments that are not necessarily equal, but the steps are going to be the exact same as construction number 10. So, bottom third of the paper. Step number 1, draw a long line coming off one end point at an angle. Draw a long line coming off one end point at an angle. Draw a long line coming off one end point at an angle. And again, it's going to start out a lot like, it's pretty much is going to be just like construction number 10, except I don't have to mark off 5 or 4 or 7 or however many segments. I'm going to mark off only my given segments. That's step number 2. Mark off the given segments in succession on the long line. Mark off the given segments in succession on the long line. So we'll mark off A. We'll mark off B. And I'm going to run out of room. And we're going to mark off C eventually. C is too big to fit.
Does it matter the order you mark them off in?
Yes, you will mark it. Well, technically, no. It just depends on the order that we would write these down. Typically, we'll just mark them in the order given, because changing the order changes nothing about the process. So, probably easiest just to take them in the order given. All right. And you might recall scribbling off the excess and stuff like this. You also might recall making little dots, or perhaps even numbering these before 1, 2, and 3. Again, you don't have to do any of those things, but it doesn't hurt. All right, so step number 3, you might recall, was to connect the end of the last segment to the free end of the given line. Connect the end of the last segment to the free end of the given line. Connect the end of the last segment to the free end of the given line. I think we're on step 4 now. Step number 4, construct parallels at the ends of the other segments. Construct parallels at the ends of the other segments. So again, that's going to involve make an arc, make an arc, make an arc. Measure across, measure across. Ooh, that one just fit. Measure across. Connect the dots, connect the dots. And if there were more segments, you'd of course do more arc, 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 measure, 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 connect, connect, connect. And there's A prime, there's B prime, there's C prime. Not equal to A, B, and C, but exactly proportional to A, B, and C.
Can you read step number 4 again?
Yeah, connect or construct parallels at the ends of the other segments. Construct parallels at the ends of the other segments. How many feel like, yes, this is pretty much just like the other, except instead of opening your compass a random amount that you think will fit and marking off whatever that number is, you have predetermined segments to mark, which almost maybe makes it easier. You don't have to make a decision. I found most people in life would rather not make decisions if they don't have to. Like, where do you want to eat? Oh, that's a fun one. Unless you have one restaurant you just always choose. How many have a restaurant that anytime you're given the choice of where the family eats, you always choose the same one? How many of you never can figure out where you want to eat because you like so many things? All right, what's your go-to? Steak and Shake.
I don't blame you for that. Texas Roadhouse.
Oh, I love Texas Roadhouse.
Their bread is
amazing, and they cook steaks better than any other steakhouse in town. At least locally, that's true. If you're watching on YouTube and you have a horrible Texas Roadhouse, I'm sorry. We have a great one here in Columbus. Service is great too, by the way. Yes.
For fast food, McDonald's.
McDonald's is your go-to for fast food. What if it's not fast food? What if it's just anywhere? You never get to choose those. Steak and Shake, you like Steak and Shake? Who was the other one? Was it Ethan? You've got to go to. You always choose. Jason's Deli.
their Alfredo's pretty good.
They're who?
Alfredo.
That's what I get every time.
Okay.
Great
Well,
minds
I've only been there once.
You probably got the salad bar.
No. I got some sort of like crab and corn chowder or whatever. It was really good
No,
soup.
I got that.
I think I got a sandwich too. I don't remember what it was. It wasn't a super memorable experience, but it was good. It was fine. Anyway, questions on this construction? All right, well, we will continue practicing this more tomorrow. Have a wonderful rest of your day, and you are dismissed when the bell rings.